Hello, Algebra 2. We are going to take care of CFR1, CFR2. Quick quiz 1. That's my version 2. Don't worry about that one. That's all you need to know. So let's go ahead and take a look at this business. We'll start with the left-hand side first. It says, find the domain in the following notations of this function we got going on here. Well, what we're going to do, we're going to start with, is there anything restricting x from going left and right? In other words, is there kind of like an endpoint on either end? And in this case, there is not. There's nothing stopping x from going to negative or positive infinity, because if I draw these arrows and keep them going, they'll just keep right on going. So I'll always have an x value to give me a y value. That means my small x, try that again, my small x is negative infinity. My big X is positive infinity. And when I do that, that means I've got the set of all the real numbers, and that gives me that symbol, all real numbers. It's that guy right there. Okay. And set notation is kind of nice. We say the set of all numbers in X such that, that's that vertical line, we have the set of all real numbers. And in interval notation, we do have to go small to big. So that's from negative infinity to positive infinity. And since we don't have an exact value for those, we don't put brackets, we put parentheses. All right, let's look at our y values. Do I have arrows pointing down? Let's go ahead and change colors too while we're doing that. Do I have any arrows pointing down indicating that I would have my smallest as negative infinity? Small y. And I do. I've got arrows that are pointing down, which means my lowest value is negative infinity. And I'm looking for my big Y. My big Y in here. And I don't have any arrows pointing up, and I have this value. This is the top value I have. What's the Y value right there? That is 8. My biggest Y value is 8. I think it touches, so I'm going to make all my notations look like it touches. So I've got Y, and I've got 8. I need to have things that are smaller than or equal to 8. So I should say Y is less than or equal to 8. And if I'm writing set notation, I just put my fancy brackets and say Y, all the numbers, the set of numbers Y such that Y is less than or equal to 8. Got that business. Interval notation, we write our smallest, which we said was negative infinity. Our biggest, which we said was 8. We obviously, we don't know the number for negative infinity, so we're going to put a parenthesis on there. We did say it touched 8 though. We've said that in the other two notations, so I'm going to put a nice little bracket on there. If you don't think it touches, make all the notations say it doesn't touch. All right. This one here, the end behavior as as x goes to positive infinity. In other words, so look at the right-hand side of the equation. Do I have an arrow? I do have an arrow. Since I have an arrow, I say what direction is it pointing in? And it's down. It's going down for real. So that is negative infinity. Down is negative infinity. Now I look on the left-hand side. On the left-hand side, do I have an arrow? I sure do. And where is it pointing? Also pointing down to negative infinity. And again, that's taking care of your 1 and 2 level work for CFR1. Let's go ahead and start on the CFR2 business. We'll do our 3 level here in a second here. Now we need to look at on which intervals is the function increasing. So I'm going to get rid of this stuff for now. Increasing, in other words, where is it going up as I'm reading it like a book from left to right, right? And it's going up. It's always going to be going up, going up, going up, going up, and that stops right there. And again, when we're talking intervals, you're reporting the x intervals. Increasing already takes care of the y's. Increasing says it's going up or down in y. What is the x interval in which that occurs? Well, it's always going. Headset turned off. There we go. It's going up all the way, all the way, all the way, all the way. Then it stops going up right there. So from negative infinity until -6, that's an interval where it's going up. All right. Now, if I look for the next part, this part is actually going down. That's a decreasing interval. From here to here, this function is going down. So from starting here and ending right here, that function is going down. If that function is going down, it's going down from -6 when x is -6 to when x is -2. From there, I start to go back up again. going back up again, right there. And I go up from -2 until 6. So it's increasing from -2 to 6. And then from here, it starts decreasing again. So this is an increase. And then it starts decreasing again, starts decreasing right there for the rest of time, or for the rest of the function anyway. So from 6 until positive infinity, it is decreasing. All right, that's like this. Now, go get rid of that stuff. Let's take a look at our next thing. It says what are the relative or local maximums? Notice how this doesn't say interval. This is a coordinate point. Coordinate point. So those other ones, we were doing an interval notation up here. So these are intervals. It's either X intervals. Here we're going to do, these two are going to be coordinate points. And what are those coordinate points? A relative or local maximum is the top of a hill where it goes from increasing to decreasing. There's that value right there. I've also got another one here where it goes from increasing to decreasing. And if I do that, I'm saying I need to report the Y value and the X value. So how I like to write this, so I remember that I'm doing coordinates, is going to be 6 at X equals -6. You could have also written -6 comma 6 here. Again, that's a coordinate, not an interval. We said a second one we have 8 at X equals 6. Very interesting, very interesting. And we said right there, we could have also written 6 comma 8. And you'll notice that that happens from increasing to decreasing. At -6, it switched from increasing to decreasing. At positive 6, it switched from increasing to decreasing. We also have a valley, a low value down here, where it goes from decreasing to increasing, which is our local minimum. That value is -9 at X equals -2, or you could have called that -2 comma -9. Okay, however you want to write it. This is one of those times though I need to know it's an X value and a Y value. Got to have both. X-intercepts, literally, where does it cross the X axis? And it crosses here and here and here and here 4 times. Write them down. -8, -4, 3, and 8. Okay, next part says, where is the function positive? In other words, where is the function above the x-axis? Where is the function up in here? Well, if I look at it, the function is positive. The function values exist. I got it from here, and so oops, here we go. They're positive here. So from here until here, it is positive. And it's also positive. It's above the x-axis from here until here. Again, it's asking on what intervals? Intervals mean X intervals. So where are they positive? From -8 to -4. Interesting numbers. It's like, you know, some of these mean something here. -8 to -4, and also from 3 until 8. Let's look now for negative values. We will go ahead and change this guy out. Change the color, do a blue. Negative values. In other words, when is the function below the x-axis? When is the function below the x-axis? And that happens in 3 different spots. What are those spots? Let's find out. Go this green color, why not? Well, it's negative from -infinity and then stops being negative right there. So from -infinity to -8, it is negative. Right? Because my function values are all down here. And then it's negative here. So from here until here, so from -4 until 3, by the way, sorry, -4 until 3, it is negative. We got one more section here, starting at 8 and continuing on for the whole time, the whole rest of time. it is negative. So from 8 until positive infinity. Remember, we're describing the x values. Now, next part, last part on here, identify a positive rate of change, a negative rate of change, and a zero rate of change. Pick two x values that give you a positive rate of change. What if I said if x was -6 and x was 6? If I draw a line between those 2 points, let's pretend like I drew the line between those 2 points. That's a little better. If I drew that line right there, that's a positive slope. I'm going to say between -6 and 6. Those 2 points would give me an average rate of change that's positive. So from -6 to 6, this is an example. And again, I'm back to intervals, so I'm talking about x's. Back to intervals, so I'm talking about x values. That's my example here. Your answers will vary. Answers will vary. There's an unlimited number of right answers and an unlimited number of wrong answers. So a negative rate of change would be going down. Let's see here. What if I stayed here? What if I did -6 and then picked, I don't know, 3? If I drew a line between those 2 points, that slope, that rate of change would be negative. Why not? So from -6 to 3, again, that's just an example. And the zero rate of change is going straight across. I don't know. How about from -6 to that value right there? Would that give me a horizontal line? Horizontal line is a zero rate of change. So from -6 to 5, how about that? Again, just an example. You could have totally different values. Whoa. From -6 to 5. You could have completely different values, but as long as those two values go from small to big and those x values give me a positive, a negative, or a zero rate of change, we're good to go. All right, let's do everybody's favorite, which is the 3 level. Again, this is 3 level for CFR1. And this says graph the following function with a given limited domain. Write the range in the same notation as the domain. Well, in this case, again, this is linear. This is a line. Okay, and it's saying my smallest x value is -1, and my biggest x value is positive infinity. It can't touch -1, so it's going to be an open circle. And since it goes on forever, this is going to be a ray. This is going to be a ray. And this is also an interval notation. So when we figure out the range, we also need to write that in interval notation. So here's what I'm going to do. I'm going to find the smallest value that I can have. The smallest x value I could have is -1. What is my f of x value or my y value there? So let's plug it in. The value of the function x is -1 is 3 times -1, which happens to be -3. So at the point -1, -3, I'm going to put an open circle. -1, -3. And this is a line, right? This is a line. We've already talked about how this is a line. Y equals mx plus b. This is like 3x plus 0. So I could use my slope to find another value. Now, this is the furthest left I can go, right there at -1, -3. I have no values out in here to the left. I can only have values to the right. Well, let's use the slope to find another point. I go up 3 and right 1, up 3 and right 1. Notice how I'm not making it a big dot or a big open dot or a big closed dot, because this is just finding other values to graph with. And if I do that, I end up with something that looks like this. This is that function. This is the function of f of x equals 3x on the domain of -1 to infinity. We need to figure out the range. What's the smallest I can have? The smallest y is -3. The biggest y is positive infinity. My range goes from -3 to positive infinity. Well, we know we got to put a parenthesis around positive infinity, but here this is an open circle, so we still put a parenthesis. And that is how you take care of that. Hope you're doing well. Take care. Talk to you soon.